Today, we start with a concept, what you call flowcharts, flowcharts, and related topic, algorithms and flowchart. I told you in the previous session, analysis. Analysis is nothing but gathering of information, isn't? We have a concept, what you call analysis. Analysis is nothing but gathering or collecting information about the problem. Analysis is nothing but gathering or collecting information about the problem is called analysis. Gathering of information, collecting of information. What is gathering? What is collecting? Listen. Any information about the problem may include a model, what you call, what is meant by input, what is output. It determines the following aspects. What is the input? What kind of process or a formula you need to apply? What kind of output you are producing? There are three stages. Number one, analysis. Analysis is nothing but gathering of information, collecting of information about the problem. It includes input, process, and output. Here we have what input need to be given to the machine, what input need to be given to the machine, what kind of process you are applying, what output you are producing. For example, I want to write a program, or I want to solve a problem that is in the terms of addition of two numbers. What is that? Addition of two numbers. Your problem is addition or sum of two numbers. Here we have analysis. Analysis includes, I told you, 3 points: input, process, and output. What is the input? Here, input is two numbers, A and B. Or you may take X and Y. You may take X and Y, L and M, your wish. That is totally your wish. Second one is, what is the process? We need to calculate the sum value. Sum is equal to A plus B. A and B are added and that will be stored in sum. What is the output? Output is sum. This is analysis. Analysis is nothing but a model where we have gathering of information, collecting of information, gathering information or collecting information about the problem. That problem may include various aspects. What is input? Here, the input is A and B, process is some A plus B, and then we can have output that is some value. Now, second, if you want to find area of a rectangle, what is the input? L and B is the input, area is output, process is area is equal to L into B. That is analysis. The second stage is algorithm. The second step in the case of our program development process is algorithm. What is algorithm? Algorithm is nothing but a step-by-step process for solving a problem. A step-by-step process for solving a problem is said to be algorithm. If you want to solve any problem, that problem may not be solved directly. That may not be solved directly. What we require? You require a step-by-step process. In order to solve this problem, for example, I want to write an algorithm for addition of two numbers. Listen. Step number one is nothing but a start. Step number two, you need to read two numbers, A and B. You need to calculate some value, compute sum is equal to A plus B. We need to print a sum value, print sum. Finally, this algorithm need to be ended, stop. You may use either stop or end. You may use either stop or end for algorithm ending. This is the second step in the case of solving a problem. What is the first step here? Analysis. What is analysis? Gathering of information, collecting of information. What is algorithm? Algorithm is nothing but step-by-step process for solving a problem. Next one. Next one is flowchart. A flowchart is nothing but graphical representation of or a pictorial representation of algorithm, which means that if you represent the algorithm in a graphical fashion, we have a component what you call a flowchart. A graphical representation of an algorithm is said to be a flowchart. A pictorial representation of an algorithm is said to be a flowchart. So, if you are going to represent your algorithm in the form of a picture or a graph is said to be flowchart. Flowchart uses several symbols. You have to remember these symbols properly, then only you are able to write flowcharts properly. Right. Flowchart uses various categories of symbols. In the graphical symbols, see, A rectangle with round edges, a rectangle with round edges can be used for either start or stop. You may use stop or end. Parallelogram can be used for either reading input or presenting output. So for every flowchart, what we require? Start, stop, input, output. And the rectangle is for computation, calculation, processing activity. If you want to write something, you may write processing or calculating, computation. Anything is okay. Processing. And then we have a symbol called a rhombus. This is called a decision making. This is called decision making, also called as condition checking. Condition checking. Very, very important. This is very, very important. These symbols always provides very important. Next concept is this is a arrow marks. These elements can be used for connecting one symbol to another symbol in the terms of a flow lines. And then specifically, we are using a special symbol called, this is called a print symbol. If you want to print something, we require a print symbol. And we have a circle. This is for page connection. For example, the total size of the flow chart is very large. You are unable to complete the flow chart within one paper. At the time, we are going to utilize the system what you call page connection. Circle is a page connection. So rectangle with rounded edges is for start or stop. Parallelogram is for getting either input or producing output. Rectangle is for computation or a processing. Rhombus for decision making. Flow lines are for flow lines, arrow marks, and this is a print symbol. And the next one is page connection. If you are unable to complete your flowchart within one page, we are going to connect those two pages by using a circle. These are very, very important symbols. If you understood these symbols, then only you are able to write flowcharts. Okay, next. I want to draw a flowchart for sum of two numbers. Flowchart for sum of two numbers or addition of two numbers. What are they? Sum of two numbers or addition of two numbers. Listen, I told you in the case of analysis, input, process, output. What is the input? A and B. What is the output? Sum. What is the process? Sum is equal to A plus B. What is algorithm? Start, read A comma B, calculate sum is equal to A plus B, print some value, then stop. And follow the guidelines clearly. First, write down the content rather than the symbol. Start. What is the symbol? A rectangle with rounded edges is for start. Rectangle with rounded edges is for start. Then rectangle with rounded edges is for start. Next one, you have to read two numbers. You may use either read statement or input. Read A, comma B. What is the symbol for reading or input? This is a parallelogram. First one is start. Second one is read AB. Third one is you need to calculate the sum value. Sum is equal to A plus B, which means that A and B values are calculated and the result will be stored in sum. Then we have to print the output, that is print sum. What is the symbol? For printing output, we have a parallelogram or you may use print symbol. This is the first flowchart. That's why I'm writing a parallelogram or you may write print symbol as well. Finally, once the flowchart is completed, you have to terminate the flowchart by end. Listen. A graphical representation of pictorial representation of an algorithm is said to be a flowchart, graphical or a pictorial. What is the flowchart here? I want to find sum of two numbers, that is addition of two numbers. First one is start. Second one is you have to read A and B because I want to find addition of two numbers, that's why. And then sum is equal to A plus B. You need to calculate the sum value. Print that sum value, finally end. See, some people used to write like this. Print in double quotes sum. For example, print sum. Consider there are two statements. For example, A is equal to 10, B is equal to 20. Sum will be calculated. In this case, output will be only some whatever the content that is enclosed in double quotes will be printed. Here, output will be some value will be printed, that is 10. Got the difference? If you write in double quotes, whatever the content you are writing in your double quotes, that will be printed. If you write normal print like this, what is the sum value? 10 plus 20. Sum will be calculated. Sum is equal to A plus B, that is equal to 30. Its corresponding value will be printed, that is in the terms of 30. Got it? This is a flowchart for finding sum of two numbers. Now, I want to find area of a rectangle. I want to draw a flowchart for finding area of a rectangle. Listen. What is the first statement for any flowchart? Start. What is the first component? Start. What is the symbol? Rectangle with rounded edges. What is the input to be taken? Area of a rectangle. What is the formula? Area is equal to L into B. This is a mathematical formula. So we have to read L comma B. Somebody used to say that, sir, I want to read L and B in the form of length, comma breadth. Yes, you can take it. These are variables. You can choose any name. Len, B or E may be accepted. L comma B may be accepted. Length and breadth may be accepted. But why I'm taking L comma B is that in order to reduce the size of the symbol, I have taken read L comma B. What is the next statement? You have to calculate area. Area is equal to L into B. I am calculating, computing L into B. Once its work is over, I have to print area in the terms of a print. I told you, you may write directly parallelogram for printing the output, or you may use a print symbol in order to habituate all the symbols. I am starting with one by one. See this. Start. Read L comma B. Area is equal to L into B. Print area. But this is totally wrong. That is completely wrong. Why? Why completely wrong? See, in the case of mathematics, this is called L into B, but is not in the computers. It can be computer may treat this one as LXB, not L multiplied by B. That's what you have to write, L into B like this. So LXB is not L into B. What is L into B? L multiplied by B. L multiplied by B. Start. Read L comma B. What is L? Length. What is B? Breadth. Area is equal to L into B. Print area. Finally, end. Or you may write something like this. In outside, if your flowchart may be seen by any other person, they don't know what is L, what is B. For that, you may write outside L is length, B is nothing but breadth. Is there any need for writing area? No, there is no need to write anything for area. For example, you may utilize A instead of area. People may not know what is A means. That's why you may write A area. Okay, this is a flow chart for finding area of a rectangle. Got it? Right. Next one. I want to find area of a circle. I want to draw a flow chart for area of a circle. As you know, what is area of a circle? Area of a circle is equal to 3.14 into r square. R is nothing but radius. So, in the case of computation, you have to write 3.14. See, it is not supposed to write directly 3.14 into r square. Computer may not understand that. 3.14 into r into r. R square may not be allowed. R into r. What is r into r? R square. What is this? Area. What input need to be captured? R. Only radius. Listen. First term is a start. I told you for every flowchart, we require a start. Second one, we have to read a radius value. I told you, you may use read statement or input. You may use either read or input. Anything is okay. People may not understand what R means. So if you want to write something, you may write R means that radius, which is more clear. That is not for you, that is only the people who views your flowcharts, they are unable to understand what it means. That's why flowchart is always providing graphical. That's why it can provide you easy to interaction. What is the formula for area? Area is equal to 3.14 into R into R. I told you, computer may not evaluate complete information at a time. If you want to calculate area is equal to 3.14 into R into R. Is it okay? Right. What is the next to execute? We have to print the output. Print what? Area. Area need to be printed. You may use either parallelogram, I told you, or you may use a print symbol. Finally, that need to be concluded in the terms of end. Every symbol need to be connected by using arrow marks. What you call it's a flow line. What is that? Flow line. Once again, area of a circle. Draw a flow chart to find area of a circle. What is the formula? First, you have to remember the formula. 3.14 into R into R. This is 3.14, 3.14 R pi R square. But our people used to say that it's a pi R square. But computer is unable to identify pi R square. Pi is a symbol or it has some meaning for human being, but the machine cannot understand what a symbol pi means. That's why we are converting this pi r square into this format. Area is equal to pi is a constant. Its value is 3.14 into r square. So r square can be written as r into r into r. Okay, 3.14 into r into r. So start, input, area, print, and then stop. And then we go for some more flowcharts. I want to find the biggest of two numbers. Up to now, we have seen only the flowcharts in the terms of sequential execution. What is sequential execution? One after another. One after another. Now, our topic is finding biggest of two numbers. What to do? What input is required? Two numbers required, A and B. Your wish. You may take either X and Y, L and M, A1 and A2, your wish, or N1 and 2. But for simplicity, I'm taking two numbers A and B. Let us start. For any flowchart, the first statement would be start. For this, we have a rectangle with rounded edges. Then you have to read two numbers, read A and B, A comma B, or you may write N1 and 2, or you may write X comma Y. That is our wish. Variable selection is our wish. And then up to now, we have not utilized this symbol. If you want to find biggest of two numbers, what we require, you need to compare these two numbers. How? Here, I'm using a symbol a decision making symbol. Rhombus. It is also called as condition checking. Within rhombus, you have to write a question mark, or is, or if. Whenever a condition is executed, always we have two categories of states. Number one is yes, second one is no. See, is it? Here initially I'm taking two numbers. Then what happens? Then what happens? Condition testing. A is greater than B. Yes. So A is greater than B. Then what to print? You have to print A value. A is greater than B, which means that A is big. If it is not true, A is not greater than B, then which one is bigger? B may be a bigger. Then what to do? We have to print B value. Very simple logic. Anyway, you have to make the flowchart end. Every flowchart should have only one start and one end. But this is a totally wrong flowchart. I will tell you how. For example, start, read A comma B. For example, A is equal to 20, B is equal to 10. This approach is called as a tracing. What is the next statement here? Is it 20 is greater than 10? A is greater than 10. What happens? Yes. What yes? It prints the value what? A. What is the value of A? 20. Finally, end. Very good. For example, consider another scenario. A is equal to 10, B is equal to 50. Now tell me what happens. Here the condition is 10. 10 is greater than 50. No, right? This is no. Then what to print? B need to be printed. What is B? 50. Then what happens? Then what happens? Is there any connection in between end and print B? No, this program will not be terminated. That's why after printing B, you have to connect this process to end. I told you for every flowchart, we have only one input, one start and one stop. Okay, that's all.